Hey there, students. It's Miss Adams, and in this video, we're going to learn about inference for sampling.
All right, so a simple random sample, or abbreviated SRS, is a sample chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. Sampling variability is the fact that different random samples of the same size from the same population will produce different estimates. All right, another important thing to note is that increasing the sample size does not reduce bias. So if you collected your data in a biased, using a biased method, even if you take a larger sample, it's still going to be biased. All right, an example of selecting a simple random sample. A safety engineer at an automobile assembly plant knows that 180 pickup trucks will be assembled tomorrow. To meet federal regulation, the engineer must select 5 of those vehicles for safety testing. Describe how to select an SRS of 5 trucks using slips of paper. All right, so we could assign each truck a unique number from 1 to 180. Write the numbers 1 to 180 on identical slips of paper. Put them in a bag, shake the bag, select 5 slips of paper, and test the trucks that were assigned those matching numbers. All right, and we would want to take those pieces of paper out without replacement, meaning we're not going to put them back in the bag. Describe how to select a simple random sample of 5 trucks using a random number generator. All right, so again, I would assign each truck a unique integer from 1 to 180, randomly generate 5 integers from 1 to 180, ignoring repeats, and then I would test the 5 trucks that were assigned those generated integers. All right, an example of sample variability. A recent Gallup poll found that 55.7% of a random sample of 1,947,144 Americans eat produce often. For the purpose of this poll, eating produce often is defined as eating the recommended daily allowance of fruits and vegetables at least 4 days in the previous week. Do you think that the percentage of all Americans who eat produce often is equal to 57.7%? Explain your reasoning. All right, so we're going to say no because different random samples will produce different estimated percentages. It is unlikely that this particular sample provides a percentage that is the exact correct answer. Okay, it's probably somewhere close to 57%, but that was just from one sample. If I did another sample of that same size, I would still get a different value, most likely. If the sample size was decreased to 10,000 Americans, what effect would this have on the estimated percentage of Americans who eat produce frequently? So the estimate is more likely to be far from the true percentage of all Americans who eat produce regularly. So as I increase my sample size, I get closer to the true value. And if I take a larger sample, it's going to get more accurate results.
That's all for this video. Thanks for watching. See you next time.